Mm.
Hello everyone, this is Teja and my friend Rahul would be explaining the disease classification using chest x-ray. This is our project. So our statement of our project is the classification of 14 diseases based on our chest x-rays, which is simply it's like building a model which can either classify 14 diseases by sending a chest x-ray or labeling any of the 14 diseases. We get the chest x-rays reviewing how many cases would be under the named label disease. There are 14 diseases, but the classification is done in 15 classifications because taking a new no disease as one of the classification. And it's a just this is a famous paper implementation, which is also known as chestnut. So we are re-implementing the our research paper on this. Our project is a re-implementation of the project. And here is the architecture what we need. The training was done using a single Tesla P100, which has approximately taken like 22 hours. We can also train our model on our own computer if we aforementioned architecture are higher to have a more or same or less executing time. We can also train our models on PC equipped with GPUs only, but it might take a longer time if you take a PC equipped with GPUs. If you take a like single PC GPU or any external GPU, it would take like very lesser time rather than running a PCU equipped with GPU. So for this, we need a Jupyter notebook, and like pyTorch is a library which we use it to develop this model. So and the further coding and execution part, my friend Rahul would be taking over from here. So hey Rahul, are you there?
Yeah, thank you, Teja. Now I will be sharing my screen so that you can all look at the code. So as you can see, this is I have developed different files so that we can you can more easily understand what is going on in our project. So the first file is the dataset file where I have imported the CSV file and the chest X-ray images so that that CSV file matches the X-ray images and stores them in a data frame for the axis for the easy axis of classification. The next file is the model file where all the dense layers and convolution layers, poolings, optimizers, and every other required parameter is used to develop our model and train it. The next file will be the training file where we have used the learning rates and weight decays to train our model. The next file is the evaluation file. This file evaluates the predicted outcome from the training file with the actual output of each image so that we can have an understanding of accuracies. All the previously trained model weights and the image classifications are saved so that we don't need to rerun the model each time to predict a new image. The visualization file will explain us how the diseases are in each image. So I'm going to show you how it is done. So here we have taken a sample of images and run the model with the pre-trained weights so that you can see here the left side is the original X-ray image and the right side is the image with correlation map showing the predicted probabilities of diseases. There is a slight color here where my mouse is pointing, where it is indicating that there is a infiltration disease there. So the table below shows the different diseases that are shown in the X-ray image. I'm going to show you another Jupyter notebook which takes the chest X-ray images dynamically. So this is that file. You can see that we have given a chest X-ray image dynamically here. What it does is this takes the image and the model calls the uh, pre-trained weights and the image will be transformed into the required format so that the model will be run on it and the classification diseases will be shown here. You can see that there is a pneumonia disease in the provided X-ray image. The value for it is shown here. So the future work and other aspects will be discussed by Teja. Teja, you can take over from here.
Yeah, Rahul. 1 second. So my friend Rahul has further discussed like how he has taken, but I will just make a bit clear about how the visualization file help you guys in a in a layman manner. It's something like we have uploaded this in a PNG file. So we like yeah, actually a chest X-ray would be in a very different format or a different extension. So we have converted into the PNG file, and we have converted into the grayscale, and we have converted the RGB file, and we have overlapped with the correlation matrix over here. And if you see the region over here, this is the most probably and most affected region of the X-ray where there is a pneumonia over there. And if you see here, the best part is like here we can just only see that pneumonia, yeah, it has passed the cases, and it is true that it has only pneumonia. But along with, there's a slight of 0.1 chances that it might have infiltration. That's because of our testing cases which we have done, and it's the trade model which there where we have. And if we see our next page, if we see the prediction value where our in a first Rahul discussed about the infiltration part, if we take that table, you see the infiltration. Along with the infiltration, there is a high chances, and it has affected that it has effusion and atlasia. There are if you see the prediction tables are very high. So this case, the chest X-ray must be reviewed through the effusion and atlasia also. We have, if we go through that label, it has a chances of like other two other like infiltration and atlasia will have the high prop prediction tables, and is the ground truth is true over here. So yeah guys, that's how it's been done, and we have done the most of our work. There's only very last like 20% of our work to be done. It's something like if you want, we would like to make it more accurate and using a different values. We want to retrain the model using different values to see whether we can increase any accuracy using GPU, or if we, is there any chance we can build our own model rather than come using the dense network or some other network. So if you guys have any other doubts, you can check it, we can check it on our GitHub, but it's not uploaded yet. It will be uploaded in a couple of days, and we will make some alteration and corrections, and our final report would be in the GitHub and readme. So any doubts, you can just reach me out guys, and thank you.